we're going to do here, this is just going to be a recap from yesterday, okay? So we've got like, what is a vertex, the axis of symmetry, optimal value, okay? And these were all terms that we kind of looked at yesterday, right? So what I want to concentrate on today, this is going to be the recap from yesterday, and then we're going to flip. I'm going to provide you with the information this time, okay? And you're going to produce the graph over here, all right? And these can kind of be sketches too, they don't have to be perfect, okay? But let's go to the top here. First, we'll review what all this stuff is, and then we can go down and do the opposite process. Okay, so the vertex, and I'll try and do these. Maybe I'll do these in different colors. The vertex is the higher low point, right? It's like a point. Okay, it's like the I don't know. It's like the crest of a hill, right? Or the valley. Okay, so. Maybe I'll write that on here. Okay, that's what the vertex is. Okay, so we go to our graph and we identify that point, okay, which I see is right here. Okay, and then all you're going to do is tell me what this point is. So you're going to read it off, right? So the point, you have to go, remember it's always x first and then y, right? When we write out points, they always look like this, so you don't flip. Sometimes kids like to do this. And then that tells me if you put like, if I were to go plot this point, 2 and 5, 2 is here, and 5 is up here. Well, that point is different from 5, 2, obviously. 5, 2 is way down here, right? And so sometimes kids write the vertex backwards, and then I have to give them half a mark, even though I know they know what they're doing. They just flipped it. Okay, so don't make this mistake. It's always x and y. Okay, so you go find the point on the grid, or the vertex, right? And this one has an x value of 1, so you're going to write 1, and then -4. Okay, that's your vertex. And then your axis of symmetry, and I'll give you the shortcut here after I draw it on here. Your axis of symmetry is the line, the vertical line that splits the parabola into 2 pieces, okay? 2 equal pieces, so it's like a mirror, right? So you're not going to draw the axis of symmetry over here because this half does not look anything like this half. Okay, so your axis of symmetry has to be the same on both sides. So the catch here is that the axis of symmetry actually goes through the vertex. Okay? And then when you go to write this, this is a line, right? And we know that lines have equations. So you have to write this, when you tell me what the axis of symmetry is, you have to write it as a line. Vertical lines take the form of a vertical line in terms of an equation has to be x equals something. It's that because if you look at the x value on, if I draw a whole bunch of points on here, and I want to go label all these points, the x value of all of these 4 points is always 1. Always. Look at this one. We've got 1 and 2. This one is 1 and 5, and this one is 1 and 6. Right? You can see how the x value is always 1, so it takes on this form. X equals 1. Okay, so when you go over to your axis of symmetry, x equals 1. Alright? Now the kind of cheating way to do this, without much thinking at all, is to recognize the fact that x equals 1 is actually the value of the vertex. Okay, and I told you the axis of symmetry has to go through the vertex, so it better go through the value of 1. Okay, so as soon as you guys find the vertex, you automatically know the axis of symmetry. Okay, so I'm just going to clean this up here a little bit. Okay, my lose the line. Yeah. Okay. Do we have any questions? I can't see the chat here. Okay, so this is just a little bit of review from yesterday, okay? We're just gonna keep labeling stuff, like this is all this is about, right? We're just identifying information on the graph. Okay? And if I wanted to, x equals 1, you can label it on the graph, okay? Now the optimal value is still talking about the vertex, right? We still use our vertex to inform our optimal value. The optimal value talks about, like, specifically how tall or how low, how high or how low the parabola actually goes, right? So least or greatest value. Well, this one here, because the parabola is opening, well, I suppose we could fill this out. It's opening up, right? And I know it's opening up because it's not frowning down, right? Okay. It's not doing that, right? So I know it has to be up. When a parabola opens up, like this one, you know it has to reach a minimum, okay, or a least value. So you're going to write, okay, we're going to reach a minimum. What is the minimum value? Oops. I'm going to save myself some space here. We're going to say, okay, there's a minimum. The minimum value is -4. I'm going to write some words too. Min of -4, okay? And that's probably good. Okay, it's a minimum of -4 because it only goes to -4. Okay? And then we've got the zeros. These are important. You can see, or they've put in inside the brackets here, or x-intercepts. X-intercepts are where, remember the word intercept, to cross. Okay? So it's crossing, where it's crossing the x-axis, right? Well, x-axis runs horizontally, right? And so where does it cross that black line, or the x-axis? It crosses right here and right here. How do I write these 2 points is your question. Well, this one here is at 3, 0. Again, don't flip these. A lot of kids flip these. Don't flip them. It's always x first, y second. I have no height. I'm not up and down. I'm right on the axis, right? And so my y value is going to be 0. Okay? That's how I kind of try to remember it now. Okay? That's 3, 0, and then this one over here is -1, 0. Okay, so you go over your table and you write those. 3, 0, and -1, 0. Here's the other thing kids like to do, which I saw in the grade 10 academic. Okay? Kids like to do this. That's not 2 points, that's 1 point. That's not even close to where we're talking about. Well, I suppose it's close to one of them. But the 0.31, the 3 -1 is right here. That's 1 point. I need 2 zeros, it's plural. Okay? So don't do this either. Okay? You need 2 separate points when you write them in here. Okay? The last one is, I want you guys to find where it crosses the y-axis. Where does it cross the y-axis? Remember, the y-axis goes up and down, right? Where's it cross this pink line? It crosses right there. That's 0, -3. Okay? Anybody have any questions? So this is just a recap of yesterday, okay? And I just teaching you how to navigate the terminology, okay? To extract the information from the graph. Okay, now if I provide you with all of that information, you have to be able to go back and produce the graph given that I've given you all of that information. Okay? So that's what we're going to do next. Okay, and what we're going to do today in this lesson, there's no explicit homework sheet. I'm going to do a question. I'm going to leave, or maybe I'll do two. I'll make it fair. I'll do half. Okay, so I'll do 2 questions. You guys do 2 questions for homework. We'll go down some more. I'll do a question, maybe 2 questions. You guys do 2 questions, okay? And that'll keep it. That'll be your homework, okay? If we have time. Okay, I want to teach you how to do it also without making it redundant. And it gives you guys some practice in it too, okay? Okay. So this is kind of it's a unique skill too, because you're able to, like, just with a few points, 3 points in particular, you're able to answer a bunch of information about, like, a lot of information actually, which I'm going to teach you. But you can look at, let's just deal with this. The vertex. Remember, we're the vertex. It's just a point. So this is why we reviewed plotting points at the beginning of the course, right? Which is why it's going to be on your test on Monday. Okay. We're just looking to plot that point. Where's that point? -3, -2. Okay, well, -3 and on x. And if you guys need to, always write x, y on top of the point so you don't make the silly mistake of flipping it. Right? When -3 is here, -2 goes here. Well, where do these 2 like kind of lines crop? Right there. So there's your point. Okay. So there you go. I'm gonna clean that up. Okay, there's your vertex. You could even say vertex. Now, once you've labeled that, say, okay, well, where are the zeros? -1, 0, -5, 0. Okay. Well, again, you can always write x and y, right? So you don't make that mistake. -1, 0 is here, and -5, 0 is here. Now, if, in theory, you wanted to figure out, does this thing open up or does it open down? I don't know, I haven't drawn it on there yet. But what you guys can do is just kind of, you can connect the dots, right? Nobody's saying you can't connect these dots. It's not a scatter plot, right? There's a relationship here that was horrible. You guys will get good at drawing. It's a little hard drawing it on the iPad, but you guys will get good drawing it on paper. It's a bit easier, okay? Okay. So is that parabola opening up or down? It's opening up. And it's opening up because the vertex here is below the 2 x-intercepts. Okay, if it was above, so for instance, I'm just going to draw something here, it's not going to be too neat. If, for instance, there are your x-intercepts here, well, now the vertex is above. And so when I connect the dots, it's opening down. And this one's down. Okay. So I'm going to erase some stuff and clean it up. I don't like all the arrows. Okay. You guys look at this. The next part here asks you, draw the axis of symmetry with a dashed line. Okay, well, let's draw the axis of symmetry. Where is this parabola equal on both sides? It's not here. It's not here. Okay? The trick is, or the little hint is, if you find, I'll write this in text here because we got some room. Axis of symmetry Okay, the axis of symmetry is right in the middle of the two x-intercepts. Okay? Supposing you did not have any information on the vertex like you do in this question, right? So pretend you didn't have this information, you couldn't use it to your advantage. You can find the axis of symmetry by finding the middle of this value and this one. Where's the middle of those two values? Right here. Okay? That is also conveniently, if I erase this black scribble line, it also is conveniently the x value of the vertex. X equals -3, right? There's your equation. Okay? And the last thing you got to do is tell me what the optimal value is. Well, the optimal value is, again, dealing with the vertex. Okay, and you're always going to say, okay, is this if it's opening, you're going to make a decision. Is it open up or down? If it's up, then you have a minimum, right? As you can see here, it's a minimum, right? So we're going to have a minimum. You're going to have a minimum of -2. That's it. That's -2 because it doesn't go any lower than -2. Any questions? Comments and or concerns, I suppose. I'll take those too. Okay. So if I do one more here, okay. I'm going to go do the exact same thing now, okay. The vertex is at 3, -1. Okay, well, where's 3? Let's get in the habit of writing xy on there, okay? So we don't make any mistakes. xy. So 3, -1. That's right here. Okay, there's my vertex. All right, that's one done. Zeros. Where are the zeros? Zeros are at 0, 0. And at 6, 0. Alright, well, if I connect those dots, it's kind of shallow, this one. Okay, that looks like it's opening up, right? So I took care of the zeros. Is it opening up or down? Looks like it's opening up. And then we got to split that parabola in half. Well, you could kind of cheat and look at the fact that you know that's the... Oops. Gotta figure out where I'm drawing this question. You could figure out the fact that x equals 3 should be the axis of symmetry. Right? I know it's x equals 3. Or like in terms of the equation, it looks like this because every point along here has a value of x equals 3. Okay? So you can write that on there. And then you got to figure out, okay, well, what's the optimal value? Well, it's opening up, right? We decided that it's opening up, so again, must have a minimum. Has a minimum of -1. questions? You guys can. I don't think this is like crazy difficult. The graph itself is new. I'm not going to disagree with that, right? But the ideas behind it, you know how to plot points and you know how to find the middle of things, and this is a terminology game, right? It's like, can I come up with what each of these pieces of information are, right? Can I label them on this new graph? That's all this is. This is a fancier line, is all this is. Okay? It's got curves in it. Okay, so what I want to show you guys, and I'm going to leave those two for you guys to do as kind of homework stuff, okay? And then we're going to go down here, and I'm going to teach you something new. New, but not new. Okay, you guys know how to do this too, actually, because we kind of did it yesterday. Okay, Kojiko's having issues again today. Once upon a time with Kojiko, and then we went with Bell. Okay. Maybe that's why the attendance is down this morning. Okay. I've done so much talking this week, my throat is sore. You guys don't do any talking now. You just sit here and listen. Okay. We saw this yesterday, okay? This is like, without me telling you, we kind of discussed this yesterday with the stacking cups. Okay. I told you yesterday that the stacking of cups, or the number of cups in each stage, did not increase linearly, right? It was not a line. I didn't tell you what the equation was going to look like. Okay. You guys have done this before, though. It's just this looks a little uglier than what we have used in the past. Okay. So, for instance, if I reminded you by the fact that X represented stage number, so like our stacking cups yesterday, we would have had like stage 1 had 1 cup in it, stage 2 had 3, so on and so forth, right? We saw that was continually increasing. Okay. What we're going to do now is, I like to call these things, I got introduced to this terminology last year or something like that. Call this like it's a machine. Okay. A machine has what we call inputs. Okay, we input things into the machine, and specifically this piece is the machine, okay? We input things into there, and it spits new things out. It applies some process or something to it, and we get this new thing out on the other end. That's what you're going to write here, okay? The catch is, your inputs are these values. Okay, so you're going to like input these things into your machine where it tells you to input them, and then you're going to get something new out on the other end. Okay, so that's what this is asking you to do. And so all it's going to require is you to type things into your calculator. Okay, so if I want to figure out what the red output is, I need to take my blue inputs and put them into the equation. Okay, and then just do the math on it. So for instance, we'll do 0. Okay, so we're going to get 0 squared minus 8 times 0 plus 7. Okay, well that's equal to 0 minus 0 plus 7, which is equal to 7. So this right here, you have an input. Here, I'm going to write it out. I'm going to add a little column here. You had what you plugged in, and you now have what you got out on the other end. So you're going to say, okay, my point here is 0, 7 for this one. So then you go down here to the graph. Okay, but 0, 7 is right here. Okay, you do it again. 1, squared minus 8 times 1 plus 7 is going to equal 1 minus 8 plus 7. 1 minus 8 is negative 7, plus 7 is going to be 0. So your input for this one is going to be 1 and 0. Well, where's 1, 0? Go plot that point. 1, 0 is right here. Okay, then you do it again. 2 squared minus 8 times 2 plus 7 is equal to 4. Right? 2 squared is 4 minus 16 plus 7. That has to equal 4 minus 16 is going to be negative 12 plus 7 should be negative 5. So you get 2 and negative 5. Okay, this is starting to look interesting. Okay, let's do the next one. 3 squared minus 8 times 3 plus 7. And that's equal to 9, because 3 squared is 9. Or minus 8 times 3 is going to be minus 24 plus 7. Okay. Sometimes you can rearrange these. These start to get ugly for you, right? Or you can type them in the calculator too. It's going to do the math for you, right? 9 minus 24, right? We should get a number, whatever that number is, plus 7. Or you could think of it like, if I wanted to, I could go 9 plus 7. That's a little bit easier, and then minus 24. Or you could go minus 24 plus 9 plus 7. All of those are going to give you the same answer. This is like, you can write this in whatever order you want, right? So 9 and 7 is going to be 16, right? Negative 24 plus 16, okay? Negative 24 plus 10 should be negative 14 plus another 6 should be negative 8. Okay? So you're going to go find 3 and negative 8. Okay, and you just keep doing this over and over again. Okay, now, maybe for the next one I'm going to show you guys the shortcut. For right now, we're going to keep going, and there's only a shortcut because I recognize it. You guys are going to like learn the shortcut, okay? We're going to do it again. 4 squared minus 8 times 4 plus 7. That has to be 16 minus 32 plus 7. 16 minus 32 is going to be negative 16, okay? Negative 16 plus 7 should be negative, what do we get? 16 plus 7. Sometimes I gotta write them out too. It's okay, right? That should be negative 9. Oh, I got a little ahead of myself. That's why I was interpreting. I was looking for an answer that's not the answer. Okay, so 4 is gonna be negative 9. And this is starting to look familiar, right? Okay, and you keep going. 5 squared minus 8 times 5 plus 7. Okay, I'm going to make a prediction here before, and this is where I know what's coming, right? And I got a little bit ahead of myself for the last one. I know what's coming, so I'm going to make a prediction and say, oh, sorry, we got to write this point here, 4 and negative 9. I'm going to make a prediction that this point is going to be 5 and negative 8. So your answer here should be negative 8. And you guys want to give that a go for a second and see what you get. You're going to get 25 minus 40 plus 7. Okay? Should get negative 8. Now your question to me is going to be, how did you do that before you did the math? Or it should be. This is like what I like to call math magic, right? Because I'm starting to apply some of the tools that I've taught you from above, right? That the tool in particular that I showed you above that helped me solve that without actually having to do the math was the fact, I used the fact that as soon as I kind of like saw this starting to taper off, I knew the vertex was coming. Okay? I thought the vertex was here. That's why I like made that mistake there. I was like having a hard time. I was expecting an answer and it wasn't coming out. Okay? This looks familiar, this half. This piece here. Right? I'm going to try and draw it neat in a second, okay? Okay? We've seen that half. Now your question is like, how did you know what was coming next? Well, if I drew what we call the axis of symmetry on here, right? It looks like x equals 5. Well, look at my table. I started to see at x equals 5, I started to see some, where's this 4? Should be, oh, I put it over one spot, sorry. That's why it's out. So this is the other thing, is like, if you make a mistake and you have an understanding of all these concepts, you can catch these mistakes as you're going, right? Like what I just did, I had a point over here. I skipped a box. That's why my graph was looking a little bit funny too. So it's got to be at x equals 4, right? And then at 5, it was 8 again, negative 8. Okay, so when I connect these dots, this should look a little bit better. Okay. I can draw the axis of symmetry on, again, sorry. At x equals 4, right? It's at x equals 4 because that's where it crosses the x-axis. We define the axis of symmetry as being kind of like the mirror between both halves of the graph, right? And so if it's a mirror image, then this half of the graph over here better look like this one. Okay? So by that I mean, you can see it right away in the first point, and this is what I knew was coming. How far away is this point from the axis of symmetry? Well, it's 1. Right? So I'm just going to go, okay, same height. I'm going to count 1 away at negative 8. Right? And so I know that's the point before I even got to it in the table. I was able to find what the answer was going to be because I saw it there. I saw it starting to taper off, and then it finally hit the vertex. This was the vertex. And then I was able to know that the next point was going to be negative 8. Okay? So I go find negative 8 and I plotted it, and then I'm just going to keep going. Where's this point here relative to the axis of symmetry? Well, it's 2 away. So I'm going to plot 2 away there. Okay? And you keep going. 3 away. And then this one up here is 4 away. We've defined the parabola as being like symmetrical about an axis of symmetry down the middle. So by that definition, we're able to use it to actually fill in the rest of the values without having to, and you guys can check this to make sure that I'm not crazy, right? You guys check the rest of these. That should equal negative 5. I know it's negative 5 because it's the next one up from. It's the next one up from 8. Right? Then you do it again. That should be 0. You can see it. 0, negative 5. Okay? So I'm gonna leave those ones for you. don't bother with this yet. Okay, we're not going to do that yet. Okay, that's a separate lesson. I'll show you guys how to do that after, but just, you can plot these parabolas for now, okay? On your own. And that's pretty much it for this morning, okay? It's a good start, I think. And we're moving along, like we're not like, it's not like we're dilly-dallying, okay? What I'm going to do this afternoon is take the opportunity to kind of go back and we'll go over those formatives that I gave you from before the break. I'll give you some video solutions so you guys can rewatch them, and then I'll mark yours up and send them back to you, hopefully over the course of the weekend, okay? You guys can figure it out for the test on Monday, okay? And then